Hi class. We're still going to be talking about Laplace transforms here, and now we're going to put everything together and solve an initial value problem or two with Laplace transforms. So we're going to start out with number 2. We have y prime plus 3y equals 8 e to the 5x, and y of 0 equals 2. So what we're going to do is first Laplace transform everything in sight. So we have the Laplace transform of y prime plus 3y evaluated at s equals the Laplace transform of 8 e to the 5x evaluated at s. And going through these and splitting up the Laplace transform via linearity, we get s Laplace transforms of y of s minus y of 0, which is 2, so minus 2, plus 3 Laplace transform y of s equals 8 over s minus 5. Okay, now what we're going to do is solve for the Laplace transform of y. So I collect terms. And move things around. And here I'm actually going to find the common denominator on the right hand side. I should get 2s minus 10 plus 8 over s minus 5, but minus 10 plus 8 is minus 2. Let me make that look more like an s. Okay. And so to solve for the Laplace transform, what we have is that the Laplace transform of y of s is 2s minus 2 over s plus 3 times s minus 5. And now what we're going to do is partial fractions this thing apart and use our chart to go backward to find y. So this should be a over s minus 5 plus b over s plus 3. And we're going to get 2s minus 2 should be as plus 3a plus bs minus 5b. Collecting terms, we get a plus b s plus 3a minus 5b. So equating the coefficients of s and the constant, we get 2 and negative 2 on the left, and a plus b and 3a minus 5b. And once again, we could write this as a matrix and use our calculator to solve it, but it's not too hard to see that by substitution or elimination, whichever version of solving two equations with two unknowns that you want, that you actually get 1, 1 as your solution. Let's just go through and check this. 1 plus 1 is certainly 2. 3 minus 5 is definitely negative 2. So this is the solution. So we have that the Laplace transform of y of s is equal to 1 over s minus 5 plus 1 over s plus 3. And so y of t should be e to the 5t plus e to the negative 3t. So this is what I would say is a basic initial value problem. There was nothing really tricky in the use of the rules going backward. We'll always have to do partial fractions. So that much you can expect. But here, both of these were directly on the chart. In the next example that we're going to see, that's not the case. So this is number 9, if I can read my own writing. We have y prime plus 1/20th y equals cosine t times the Heaviside function of t minus pi. And our initial condition is that y of 0 is actually 0. So first, Laplace transform everything in sight. And we're going to get S, Laplace transform y of S, minus, in this case, 0, because minus y of 0, which is 0, plus 1/20th Laplace transform of y of S, equals, well now, this is going to be e to the negative pi s, Laplace transform cosine of t plus pi. And we're going to have to use our cosine addition formula. So over here, we're just going to get s plus 1/20th Laplace transform y of s equals e to the negative pi s, Laplace transform of cosine t cosine pi minus sine t sine pi. And we're going to note that the sine of pi equals 0, so this term vanishes. So ultimately what we get is e to the negative pi s. Cosine of pi is -1, so negative Laplace transform cosine of t. And this is equal to e to the negative pi s times -1 over, negative s over s squared plus 1. This is still equal to s plus 1/20th times the Laplace transform of y. So when I solve for the Laplace transform of y, I get e to the negative pi s times negative s over s plus 1/20th times s squared plus 1. And we're going to have to partial fractions the thing in brackets. Okay, so we're going to do that up here. Negative s over s plus 1/20th s plus 1/20th s squared plus 1 is a over s plus 1/20th plus bs plus c over s squared plus 1. And when we multiply this out, we get as squared plus a plus bs squared plus 1/20th bs plus cs plus 1/20th c. And so, as usual, by equating coefficients, we get our system of equations. The coefficient of s squared is a plus b on the right. The coefficient of s is 1/20th b plus c. And the coefficient of the constant is a plus 1/20th c. And in this case, I would try to simplify my work via the use of matrices and technology. So this is what we get for our matrix, and we'll come back in the next video and solve it since we need a little bit more space. But we'll be back.